Hi Huskies, we're on day 3 of the circles unit. So this is called inscribed angles. So I want you to think of inscribed. So thinking inside, inscribed. Here we go. So an inscribed angle is an angle with the vertex on the circle. So the vertex is the inside of the angle. Okay? So that's the inscribed angle. The intercepted, so let me color code this magic. So purple is the inscribed angle. Vertex is on the circle. The arc intercepted, so think of interception, is the part inside the angle that's part of the arc. Arc, again, is just a portion of the circle. Okay, so it's like if you take a piece of it, piece of the pie. So that's the arc. And then measure of inscribed angle, it's the angle. So if this is half the intercepted arc. So if this is 2x, this will become x. Okay? So let's try those out. So find the measure of the indicated arc or angle in circle O. So if the angle here is 23, well, what is double that? So you're going to do 23 times 2, and that's 46. Okay? So the arc is double the size. So if the arc is 162, well, think about how small that angle is in comparison to the huge arc. So I'm going to do 162 divided by 2. Okay? So find out what half of that is. That's 81. So 81 degrees is the angle. So if you see this symbol, we're talking arc. And if you see this symbol, we're talking angle. Okay? All right, so what does this symbol mean? Well, we're talking angle. Okay, well, I want to find out what this is. So first I have to figure out, well, all circles add up to 360. So if I have 120 and 140, I'm going to do 360 minus those two angles. So 120 plus 140. So those two arcs, I'm going to add together and subtract from 360. So 120 plus 140, subtract that from 360, and I've got a hundo. So 100 is right here for the arc. So what's 100 divided by 2? So angle R is 50. So again, are you trying to find the arc? That's double the angle. If you already have the arc, divide it by 2. So are you timesing by 2 to make it bigger, to find the arc, or are you dividing by 2 to find the inscribed angle? All right, now here we go. So this is 27. Okay, so BC is the arc. So I'm trying to find the arc. So I'm going to times it by 2. Okay, so 54. All right, if this BC is, so this is about central angles. So do you guys remember central angles? So because it goes through the center, the arc is the same amount. So that's also 132. Okay, so if the arc is 132, how do I find out what BAC is? A is the middle, so that's the vertex. So how do I find that angle? Well, it's 132 divided by 2. And that is 66 degrees. Okay, so again, are you going to be dividing by 2 or multiplying by 2? All right, next concept, two inscribed angle theorem. So if two inscribed angles share the same arc, this is a big deal, same arc, then the two angles are congruent. Okay, so for example, I have ACB, and that arc is right here. Use color, please. And then I have this angle right here, and they have the same arc. So they share an arc, so therefore these angles are congruent. Okay, so let's try some. So I've got, we're going to get hardcore right from the beginning, y'all. Okay, so I have CAD, this angle, and they have the arc of CD. Okay, let me get a new color. Boop. And let's look at this angle, CBD. Oh, they share the same arc. So therefore, these two angles are congruent to each other, and I can solve. Okay, so I want to move my x's together, so I'm going to subtract 2x to both sides, and I get 13 equals x. I don't need to divide anything, and I have x equals 13. Okay, so I don't really need to know what the arc is. I just need to know if they share an arc, therefore these two are congruent to each other. Okay, same thing here. So I'm going to draw a line to show my angle and to show the arc. I'm going to draw my angle and show my arc, and those are congruent. Therefore, these angles are congruent. So I have 6x minus 20 equals 4x. So this is a lot. I need to actually find this arc. Okay, so what do I need to do first? So I first need to find out what x is. Then I need to plug it in, and then I can find out what the arc is. So make a game plan. If you have a variable, maybe start there and see what's up. So 6x minus 20 equals 4x. All right, let's move my x's together. So I'm going to subtract 6x to both sides, and I get negative 20 equals negative 2x. Divide negative 2 to both sides, and x equals 10. Okay, how do I find the arc? Well, let's first find the angle. 4 times 10 is 40. 6 times 10 is 60, minus 20 is 40. They both should be 40 degrees. Now, if I want something bigger, I'm going to times it by 2, and that's 80 for the arc. So, first I solved for x, then I plugged it back in, and then doubled to get the arc. So again, if I have an inscribed angle, if I have x, I times it by 2. If I have the arc, I'm going to divide by 2 and go the opposite. All right, next one, inscribed right triangle theorem. Inscribed right triangle, hypotenuse is also the diameter because it goes through the center. So this is the diameter and the hypotenuse. Bada bing, bada boom. Okay, so find out what x is. Okay, well, if this is a right triangle, I can add all triangles, add up to 180. So then I can add them together and make it equal to 180. Now I don't really so because again that this line touched each side and went through the center, I can prove that it has a 90-degree angle. So I have 90 plus 3x plus 6x equals 180. So things that we've been doing for a long time now. So subtract 90 and I get 90. 3x and 6x is 9x. Divide 9 to both sides and x equals 10. And there we go. Okay, this one I have to actually find the angle B. So I first have to find the answer for x, and then I need to plug it in for angle B. Okay, so let's do that. So I have 90 degrees plus 6 is 96. And how many x's do I have? I have x plus 3x, which is 4x, and that equals 180. So I'm going to subtract 96 to both sides, and then divide 4. $84, and then divide 4 to find the value of x, which is 21. Now I need to plug it back in. So that's the tricky part. So plug that back in. So 3 times 21 plus 6. So 3 times 21 plus 6, which is 69 degrees. Okay, so are you finding the variable, or are you finding out a certain angle or a certain side? All right, inscribed quadrilateral theorems. If it's an inscribed quad, that means that it's inside the circle. Inscribed. Then the opposite angles are supplementary. There's nothing congruent, but this angle and this angle add up to 180 degrees. Okay, the same with the other ones. So this angle and this angle add up to 180. Okay, opposite angles. Right? So find the value of x. So do I know what b is? No, so I can't use that. But I can use these two numbers because they add up to 180 degrees. So combine like terms, 2x and 3x is 5x, and then 7 and 3 is 10. So subtract 10 and divide 5. And I get 34. Yahoo! And that's it for today. So thanks for joining me. I hope you have a great day, Huskies.